So in this lecture we will cover p block element. So in p block we will only discuss nitrogen family. So first we here discuss the general configuration of p block. So general configuration of p block is NS2 NP126, and then after we will talking about the nitrogen family. The electronic configuration of nitrogen family is NS2 and NP3. Now talking about the element of nitrogen family, there are the element nitrogen, phosphorus, arsenic, antimony, and bismuth. In this family, nitrogen and phosphorus are metal, arsenic and antimony are metalloids, and bismuth is typically metal. Now talking about occurrence of this element. So first we discuss about nitrogen. Occurrence of nitrogen. So here molecular nitrogen comprise 78% by volume of atmosphere in the earth crust. It occurs as a NaNO3, which is called sodium nitrate, and it is also called Chile saltpeter, and potassium nitrate, which is called Indian saltpeter. Its chemical formula is KNO3. Now we see the anomalous behavior of this element. If we talk about period number 2, there all elements show anomalous behavior. They have a small size, high electronegativity, absence of d orbital, and more ability to form p-pi bond. Here, nitrogen is different from rest of the member due to its small size, high electronegative, and high ionization enthalpy, and non-ability of d orbital, and its ability to make multiple p-pi bond with itself and another element like carbon, oxygen, which has a small size and high electronegative. Now we will talking about energy pair effect. When we move down the group, due to poor shielding effective, nuclear charge hold NS electron tightly and restrict their in participation of bonding. If I talk about NS2, NP3, then only electron in the p orbital and they get involved the bonding. Now we will talk about stability. So here the stability of lower oxidation state decrease down the group. So what will be the common oxidation state of this element? It will be -3, +3, +5. If we talk about -3, tendency to exhibit nitrogen is electronegative. If it is electronegative, then it has tendency to attack the then it is tendency to attract the electron toward itself. So it's so -3. So the tendency of -3 oxidation state decrease down the group due to increase the size and metallic character of the element. Now talking about nitrogen. So nitrogen exhibit +1, 2 and 4 oxidation state. When it react with oxygen, and phosphorus also have +1 and 4 in some of the oxoacid. Now we're talking about ionic radii, which decrease from left to right. When we go from left to right, it is decreasing in order, and when we go top to down, it is increased because down when we go down the group there is a increase in a cell, so that's why the radius of increase, so that's why the radius will increase. If we talk about nitrogen and phosphorus, there is considerable increase in covalent and ionic radii. However, talk about arsenic to bismuth. So here we will see very small increase in radii. So why it is happening? It is because of completely filled d and f orbital in heavier. Now we will talking about ionization enthalpy. It goes increase from left to right and from top to down. It will gradually increase. I am sorry, it go increase from left to right and from top to down it goes decrease. So top to down it goes decrease due to gradually increase in size. Now if we talk about the magnitude of electron gain enthalpy, it goes increase from left to right, and if we talk about boiling point, it goes decrease from left to right and it goes increase from top to down. And when we talk about melting point is also follow the same things. When we go left to right it will decrease, and when we go left top to down it will increase. Now talking about reactivity toward the hydrogen and stability of hydrides. So stability of hydride basically decrease from NH3 to BiH3. Now we will see properties of hydride. If we talk about boiling point, as we know, boiling point is directly proportional to molecular mass and van der Waals force.